I love microscopes. And this is why I'm very excited by what we have in this giant case. What it is dun dun dun, an atomic force microscope. And it's very different than pretty much every microscope I've ever worked with, which uses either light or electrons. This one does not use either of them. Instead, it literally directly touches it.
Touches what?
It! The sample! And I've already set up this little vibration isolation table.
And why does it need that?
Because when it's touching things at the atomic level, any vibration can mess up the reading.
Okay.
Also, this table is not really meant for something so light. So we just need to load it up with I think 15 pounds of weight. So we just have these random bars. These are actually from the SEM that we destroyed. But yeah, okay. I mean, I guess we'll just open this up. That's what it looks like.
Oh, that's cool.
And I should say that this specific one is made by IC Spy. Well, I should also say we're very nice and who lent this to us kind of, indefinitely to mess around with. And yeah, I'll talk more about the system in general, but I think we have to set it up. Grab this laptop. Then we got a grounding cable. Okay, yeah, sure, I'm sure that's grounded. And we're almost all set up, actually.
That's it?
Yeah, so we'll open it. We'll lift this. Okay. So, oh, I messed up. So I opened the software before starting the system, but that's fine. I think you turn it on. So if I flip it on here. Oh, I heard a little ding. Okay, so here it says AFM ready now. I didn't install the chip yet. So here, they gave us 2 sets of chips. This is a wedge tip, and these are DLC tips.
Tips? So I thought you were saying chips. Okay.
The chips have tips.
Okay, that makes sense.
The tips of the chips. So the wedge ones are less precise. So the tip radius is less than 150 nanometers, whereas this one is less than 20 nanometers. And it can do high res. So I think that's what we'll do now. And the idea is you gotta pick it up very carefully. And if you drop it, it's dead.
Wow.
But we put it here. Good. And you can kind of tap it on. Then I have a little thing. Tighten it. Nice and good. Okay. Okay. And start the computer again. Okay, so AFM ready. And if we hit sweep, this is the first step. I think that's good. I think they said that you want this line to be at the peak and this line to be just before the peak.
Okay.
What we can do now, though, is we type camera. This is cool. So, you see that little thing on the end? So that, if I turn on the light, what we see there is what's on the tip. So when you look close, you just see like a flat piece of metal, right?
Yeah, but there is a little tiny crease.
see?
You can kind of see it with the light on.
What you're seeing is this little silver lip.
Yeah.
But that's fine. That's fine.
Okay.
What I'm saying is that's that.
Oh, that's the silver lip.
That's the silver lip, and then you have this little
that I can't
little
see.
dangler off of it. That is the thing that touches the sample. But I think we're basically ready to test our first sample. So what I was thinking is maybe just like just a piece of metal. Maybe just this actually. Look, just like a random piece of aluminum.
Could work, I guess.
What does it look like? So we go back here, approach. Oh, look at that.
Oh, those are the little lines.
Yeah, it's approaching the metal, so snap it. Okay, good. So this all looks good. Let's just hit scan.
There you go. It's off.
It's doing.
So it's just touching the surface right now, like.
Yeah, and that's what it's seeing. It's pretty overall flat, I think.
What's that little peak there?
I don't know.
The little orange part.
I guess like some screw up in the manufacturing process.
Sue.
So if you go to the forward phase, this is not meant to be like a 3D thing, but it kind of shows, it does, I think, give a bit of a better visual of what the surface kind of looks like at that scale. So you can see some crud here. You can see some other crap there. That's pretty cool. But I think would be interesting to see what it's like going against the grain, right?
Yeah, let's try it.
Okay, so we've gone here. Okay, now we can shut it again. Okay, let's say reset, scan. Oh yeah, now it's going over those little bumps, man. You see?
So the image on the left is even larger than the image on the right. That's even more zoomed in.
So what the image on the left is, that's optical.
Okay.
So that's the actual camera in there just showing us what the tip is doing. So the tip's just kind of bouncing and going back and forth. And you can see the small area that it's covering.
Yeah, yeah.
That's what's on the screen here. So you can see it's the divot. It's also telling us that like the peak height is about 400 nanometers. And I guess it says the bottom is like, it's just referencing it as 0.
So that dark part is the lowest point.
Yes.
And the white part is the higher point.
Exactly. And here, I'm going to disengage. Because what I was curious about, if we go into Gwydion and we do the 3D, oh yeah, look. So now we actually have a 3D shot of what the surface in that little area of the metal looked like. So even with this, it's pretty cool. You can like literally measure the height of some of the features there, and you can also measure how big the little valley is. But that's cool, right? But I think you had a good idea, which was what?
Sandpaper.
Yes, I agree. I think sandpaper could be very, very interesting. So we got a couple samples here. We got a very gritty, this is a 150. I don't think we'll even do it. You can like just see the sand grains. This is light microscope territory. I think what we want to test though is 7,000. Because look, it feels smooth. It doesn't even feel like sandpaper. We can also see if this cheap Amazon stuff is actually 7,000 grit.
Okay.
Yeah, we can call them out once and for all.
And then we can leave a review on Amazon.
Exactly. Okay, that should be good. Okay, now we'll re-engage.
Here it comes.
Oh.
Whoa. Oh my gosh.
Okay, we're scanning the sandpaper.
You think the tip's getting sanded?
That's actually... Oh no. Oh no. No, it's not supposed to be dragging.
Yeah. It's also diamond-like, right?
Yeah, it's supposed to be tapping up and down. Okay, that's interesting. So that is, in that little tiny area, 20 microns. So in a box the size of a 50th by a 50th of a millimeter, that's what it looks like.
Yeah.
That's really cool. And ultimately, what I think is cool too, is it's telling us from the bottom, from the lowest point to the highest point, it's 5 microns. And according to Google, 7,000 grit should be between 2 and 4. They're not, it's not like it's 20 microns.
Right.
So it seems to be within the range of the proper sandpaper. Just visually, I see big chunks though. So I don't know. Maybe that could be from me. So I don't want to accuse them of anything. But I think based on this, we can, at least on the face of it, the sandpaper's not a complete lie. Oh.
Whoa,
Oh.
look at that. Oh man, yeah.
That's cool. So that's what the surface of the sandpaper looks like. Okay, well, there are definitely things to learn, but overall it's a really simple system. And it's been definitely more functional than our, what was our SEM. But yeah, either way, thank you very much to IC Spy for lending this to us. Like I said before, we have a little bit to learn, the ins and outs of the machine. But I think there's gonna be some cool stuff that we can do with it. And besides just scanning random stuff and trying to call out Amazon sandpaper, there are some really useful things we can do with it. For example, I'm going to use it to do things like get the size of nanoparticles. So in the future, when I want to make ferrofluid, I'm probably going to use it to scan the little particles that I make and to actually figure out how big they are. Because even with an SEM, that's pretty tough. I think you need TEM for that, and that's like a whole other thing. But right, I mean, this is so much better. You can have just on a little bench top, and I can, you know, easily myself test things on the nanoscale. But yeah, I think we're gonna do a lot of cool stuff with this.